Hello everyone. In this video, we are learning about model evaluation in data science. Model evaluation is basically a matrix which is used for the evaluation of data models based on their performance, strengths, and weaknesses. It is a process of evaluating machine learning models to ensure they performed as expected, achieve optimal results, and make informed decisions based on their outputs. Now let's see the understanding and importance of model evaluation. First is uncovering the bias. Evaluation helps us identify and mitigate biasness in models, ensuring fairness and reliable predictions. Optimizing performance. Model evaluation is used to optimize performance of a data model. It reveals model strengths and weaknesses, guiding improvement and fine tuning for better results. Building trust. Providing insights into model reliability builds confidence in prediction and decisions. Selecting the best model. Model evaluation helps us to select the best fit for our model. Comparing multiple model candidates allow us to choose the most effective one for the specific task. Moving forward, let's see the evaluating classification of models based on accuracy, precision, recall, and F1 score. Accuracy is used for the overall correctness of the model, how often the model predicts the correct classes. Secondly, precision. It is used for how often the model correctly identify the positive instances. Recall is used for true positives, how often the model correctly identify all positive instances, and F1 score is used for balancing precision and recall, a harmonic mean of precision and recallness. Let's see the evaluating regression models. Regression models are based on mean squared errors and R squared. Mean square error MSE, it's an average square error, measures the average difference between predicted and actual values. On the other hand, R squared is the experienced variance, quantifies the promotions of variance in the target variable explained by the model. Now let's see the handling imbalanced data sets, that are techniques and considerations. Basically, we have four techniques: oversampling, undersampling, cost-sensitive learning, and ensembles methods. In oversampling, it increases the representation of minority classes by duplicating or generating synthetic instances. Undersampling involves reducing the minority classes by removing instances, balancing the class distribution. Cost sensitive learning is a method that assigns different costs to misclassifications, prioritizing accurate predictions for minority classes. Ensembles method are the combination multiple models trained on different data sets, mitigate biasness from unbalanced data sets. Cross validation. Cross validation is the technique which rechecks the model performance, ensuring robust model performance. Splitting the data. The data is divided into k equal folds, ensuring each instance is assigned to one fold, which will be useful for cross validate the data. Training and data set. The model is trained on k1 folds and evaluated on the remaining fold repeated k times. Evaluating performance. The performance metrics are averaged across the k iterations to provide a robust estimation of model performance. Now let's see how to visualize a model performance using confusion metrics and ROC curves. Model performance is visualized using a confusion matrix. Basically, it's a matrix which displays the accuracy of the model for each class, highlighting the misclassifications. Later on, we will see how to write it code in Python language. ROC curves. Plots are trade-off between true positive rate and the false positive rate, showing the model's ability to discriminate between classes. Accounting for unequal error cost sensitivity learning in R or Python. How to account unequal errors in model evaluation. First, identify the cost difference. What are the differences between various costs? Adjust model weights. Use cost sensitive learning libraries. There are predefined learning libraries in Python or R which can be imported in the program to use the cost sensitive learnings to adjust model based on error cost, evaluate performance, measure the impact of cost sensitive learning model performances. Now let us look at some code snippet of Python languages which involve model evaluation. Here we are in the VS Code IDE where I have imported some packages like pandas, train test split, sklearn.tree, decision tree classifier, sklearn matrices, make scorer, precision call curve, sk.matrices, roc underscore auc underscore score. These all libraries are needed for the model evaluation. As usual, we have created the example of data frame for classification. We have passed the features and the target and partition the data using the modeling of data. We have learned this in the previous video, how to partition the data. Build and train a data model using decision tree classifier, which is most important for the data evaluation. Model evaluation, we have passed y underscore pred equals to model dot predict, and in the parameter we have passed x underscore test. Accuracy score equals to accuracy underscore score. In the parameters we have passed y test and y pred. Pred is for prediction, and then printing the result accuracy, passing the parameters to f. How to build a confusion matrix? We have written here conf underscore matrix equals to confusion underscore matrix, passing the parameter y test and y pred, printing the confusion matrix as required. Classification report, which includes precision and recall and f1 score. Class under wait a second. Class underscore report equals to classification underscore report, and then passing the parameters y test and y pred. Printing the classification report as required. ROC and AUC score, useful for imbalanced datasets. We use ROC and AUC score for imbalanced datasets, and again passing the parameters y test model.predict.proba x test. Accounting for unequal error cost using a custom cost metric. Define a custom cost matrix and passing the parameter in the cost underscore matrix. False negative is more costly for class and false positive is more costly for a class. Custom scoring function considering the cost matrix. Def keyword is used, custom underscore, and then passing the parameters y true and y pred. Matrix equals to confusion underscore matrix, y true, y pred. Cost equals to matrix, then passing the parameters accordingly and then returning the cost. Evaluate the matrix using the custom cost function. Custom cost function is basically used as cost equals to custom underscore cost, passing the parameter y test and y pred and printing the outcome as cust cost, accounting for unequal errors cost. I hope you have understand the model evaluation using Python. We'll meet in the next video. Thank you.